Hi, my name is Aishwan Singh, and this is my entry for the Altair Data Science contest held at Amity University, Punjab, organized by the Technometer Club. Before we dive into the project, let's first get to know Rapidminer. What is Rapidminer? Rapidminer is a powerful data science platform developed by Altair that enables users to perform data preparation, machine learning, and predictive analytics without needing extensive coding skills. Now let's see some of the Rapidminer's features. Drag and drop interface. This feature allows user to build and visualize data workflows without writing a single line of automated machine learning automobile. With this, you can quickly build and optimize models with minimum manual effort and making the process faster and more efficient. Comprehensive data preparation like Turbo Prep. RapidMiner offers a powerful tool for data cleaning, transformation, and pre-processing, ensuring that your data is ready for analysis. Wide range of algorithms. It supports various machine learning algorithms, including classifications, regression, and deep learning, catering to a wide range of data science needs. And further in this video, you will see me use all these features for my project. Now let's talk about the project itself. I have built a predictive model for forest fire prediction using RapidMiner. Now, most of you will think, why predict forest fires? Forest fires destroyed approximately 4.2 million hectares of land globally each year, contributing to 5 to 10% of annual global CO2 emissions. Imagine if we could foresee a fire before it even starts. This could save lives, protect wildlife, and conserve our beautiful forests. But how can you predict something so unpredictable as fire? Answer lies in the data. Speaking of the data, let's learn about the data set I have used for this project. The name of the dataset is Algerian Forest Fires Dataset, and the source I've picked it from is UCI Machine Learning Repository. It has total instances 244 and total attributes 12. I have shared the link of this dataset in the description of this video. Now let's take a look at a dataset. A dataset is designed to help us understand the factors that contribute to forest fires. Let us go through them one by one. Classes. This is the target attribute in a dataset. It indicates whether a forest fire occurred on that particular day and location, classified as fire or no fire. Day. This attribute represents the specific day of the month when the data was recorded. It helps us track patterns related to the timing of the fire. Month. This shows the month of the year when the data was collected. Seasonal changes can have a significant impact on fire risk. So this attribute is crucial. Temperature. The temperature in degrees Celsius, higher the temperature can dry out vegetation, making fires more likely. So this is a vital factor. RH, that is relative humidity. This measures the moisture in the air as a percentage. Lower humidity levels usually mean drier condition, which can increase the likelihood of fires. WS, wind speed. This attribute indicates the wind speed in kilometers per hour. Strong winds can spread fires more quickly, so it's important to track this. Rain. This attribute shows the amount of rainfall in millimeter. Rain can help prevent fires by keeping vegetation moist, so it's another key factor. FFMC, fine fuel moisture pool. This is a numerical value representing the moisture content in fine fuels, like leaves and twigs. Lower value indicate drier condition, making fire more likely. DMC, duff moisture level. This represents the moisture level in the duff layer, which consists of decomposed organic material. Again, lower value mean drier condition, contributing to fire risk. DC, drought zone. This is an index that estimates the long-term dryness of deep soil layers. A higher DC value indicates prolonged conditions, which can increase the chances of fires. ISI, Initial Spread Index. This index estimates how quickly a fire could spread if it starts, combines the effects of wind speed and fine fuel moisture. BUI, Build-up Index. The BUI combines DMC and DC to give a general idea of the availability of the fuel of fires. Higher values suggest more fuel is available for burning. FWI, Fire Weather Index. The FWI is a comprehensive indicator of fire risk. It combines temperature, humidity, wind speed, and other factors to predict the potential for fire. Now that we have covered the dataset and its attributes, let's move on to the exciting part, building the predictive model using Rapidminer's auto model. I have already loaded the data through the import data feature in Rapidminer, and I have labeled this attribute as label. I've changed the role of this attribute as label. And by God's grace, there are no missing values in this data, which is a good thing. Now we'll go to auto model. I've made a new repository for this data, forest fire prediction, and in its subfolder, I have added this data. We'll do predict next. I'll deselect all those routes that I don't want, and I'll select those which are required. Month, temperature, relative humidity, wind speed, rain, north pole. Next. Now I'll cancel these models because they take a very long time process and there's no need for this product. And this is a very good feature of Rapidminer that they show all the models which can be used in this product. And after seeing auto models magic, I carefully analyzed the results. One thing became clear. The models with the lowest absolute error and runtime were the most suitable for a prediction task. Among the various models, deep learning, linear regression, and logistic regression emerged as the top performers, delivering the highest accuracy. Now let's take a closer look at the deep learning model. To better understand how it works, I use the simulator feature in RapidMiner. The simulator allows us to tweak inputs variables and see how they impact the prediction outcome. For example, I adjusted the temperature attribute. As I increase the temperature, the model shows a higher likelihood of a fire event. This aligns perfectly what we would expect. Water conditions, Water conditions make fire more likely. Next, I explored another key attribute, relative humidity. When I lowered the relative humidity, the model predicted an even higher risk of fire. This makes sense, for the dry air means vegetation is more likely to catch fire. Finally, I tested the impact of wind speed. Increasing wind speed also raised the chances of fire, which is intuitive, since stronger winds can spread fires more quickly and over a larger area. By experimenting with these variables in the simulator, we can see how different environmental factors interact to influence fire risk. This hands on approach not only validates our model, but also helps us understand the real world implication of our prediction. Now I will save this process in the process panel. See, and I have saved it in the forest fire prediction repository in the process subfolder. And we can also change it to load and process data in a way that we can understand. So now I have made a logistic regression model on process panel. First, I've taken the same data, and then the first thing I did is use the normalize operator. Now, this operator is used to ensure that all our input variables were on a similar scale. I used the normalize operator in Rapidminer. Specifically, I applied the Z transformation method. Z transformation method, you can see it here. This is particularly important in model like logistic regression, where the scale of the input data can significantly impact the model's performance. Now, we know that the label is the classes attribute. I've changed the classes attribute from nominal to binomial, binomial. This conversion ensures that the logistic regression model can correctly interpret the data. And now then I have removed some of the data which was not required with the help of turbo prep, which is also a very good feature of Rapidminer, and it can help you clean and pre-process data in a very easy. And then after that, I've used the split data operator and split the data in zero point 0.7 for training and zero point 0.3 for tracing. Then I have used the logical regression model, and then I've used the apply model operator, and then I have used the performance binomial curves. And let's run this model. The result is this. All the predictions are same, and we can also check the performance of this. Accuracy is 97.2726%, which is I think is very good. And the unseen data it has predicted 3925, which is also very good. And the precision is 95.1. And I can see the description. These are the description. That was it from my side. But with the help of Rapidminer and its easy to use tools, we can create many more complex projects which can help solve many problems. Thank you for watching this video. Have a nice day.